Hello, everyone. Today, I'm going to present the project that we received the funding from DGFI this year, which is Pathways Accelerating Clean Energy, and we name it as PACE. My name is Hua Chai, and I'm currently working as a micro-credential content developer at the School of Electrical Engineering and Telecommunications. So before we delve into the details of the project, I would like to acknowledge all the project team members. So we have two UNSW electrical engineering graduates from the industry, James and Shedman, and we also have two student investigators, Yovela and Elle, who are currently undergraduate students from diverse background, electrical engineering and law, as well as computer science and commerce. So in the recent report that is released by a lot of government agencies as well as institutions, we can see a lot of shocking numbers that indicates the skill shortages and workforce shortages in Australia. And the research question that we are going to answer from PACE is how to effectively mobilize and integrate diverse talent pools to rapidly meet the workforce demands of the clean energy transition. So this is the current clean energy workforce pool that involves all the engineers and other people who are working for clean energy transition. And what PACE is looking at is four major cohorts, including curious K-12 explorers, who are the future workforce at the beginning of the talent pipeline, aspiring energy graduates, who are the emerging workforce, who are at the middle of the pipeline, and who are from the university or vocational education. Besides of these education pathways, we're also looking at the technical professionals from the legacy energy industry, from coal, from oil, mining industry. And also, today we're going to talk about this one a lot, about the skills sector shifters, those who has transferable skills from non-energy sector. So if we can leverage all these cohorts, we can have and expand the volume of the workforce in clean energy more rapidly. So the objectives and vision of PACE is to inform and inspire various audience, enable individuals and institutions to identify their own unique pace to contribute meaningfully for the clean energy transition, and to build a sustainable talent pipeline by engaging individuals at all career stages. So here we have the methodology of this project. So we are still developing a lot of case studies and a lot of works to do, but this is a very simplified version. So for this project, we start from scoping the clean energy. We define what is clean energy, what is included, so that we can have a clear boundary between non-clean energy sector and clean energy sector. Then we have two tracks. So the education pathway includes two subtracks. So we have school curriculum for school students, and we conducted a small-scale curriculum mapping for high school students. So we look into the New South Wales science syllabuses as a case study to see how to align high school curriculum with clean energy concepts. Also, we are conducting a mapping for university program and specializations at UNSW. So we are using 450 programs and specializations to align what is the pathways for the graduates at UNSW, what is the degree to career path mapping for these students. Also, for the career pathway for industry professionals, we use big data indexing to collect the job roles available in the job market, including both clean energy and non-clean energy related job positions. And then we did a skill benchmarking so that we can see the differences between these roles in the job market. And we perform gap analysis and define a career transition matrix so that people can use PACE as a tool to identify the skill shortages and the gaps between the clean energy position and non-clean energy position so that they can find their own professional development pathway, which is another pathway we are looking at. So PACE has unique workflow for each of the cohort. So for curious K-12 explorers, we need their information from their age, grade level, favorite subjects, areas of interest, and we will analyze all these information through 3 processes, and they can get their personalized learning pathways, and Clean Energy create inspiration pack, what are the available positions for them into their interesting area, and the recommended school subjects and activities, and use-friendly industry information. And also the recommended university programs. For aspiring energy graduates, we're looking at programs, specializations, their career interest, skills, and competencies, as well as what courses and projects they have been involved. So through the program specialization analysis, degree to career mapping and skill benchmarking, we can provide customized information for these university students so that they can know how to make make them successful in the clean energy transition. For those who are working in the legacy energy industry, we need to know their current roles, their years of experience, key skills and competencies, as well as their areas of interest in clean energy. So the skills benchmarking can give the information about what are the new skills they need to learn and what are the reskilling and upskilling programs they need to attend so that they can address the skills gaps and become a workforce in the clean energy sector. And for the skilled sector shifters, we need to know the current industry and the roles that they are playing in their own industry in a non-clean energy sector, and what are the transferable skills that they have, the target clean energy areas that they wish to work, and the professional strengths they have. And also, it is a similar process for them to identify the skills they need to address. But the difference between the last 2 cohorts is that for the first transitioning technical professionals, the skill gap is mostly like the technical skill gaps that they need to learn to address the new renewable energy integration. And for these sector shifters, they need to learn more about the sector-specific knowledge and skills. Apart from the 4 cohort that we mentioned, there are some other users they can leverage PACE as a tool to indicate their decision makings and their work. For example, for career guidance facilitators, what they can do is to get the information useful to advise students and professionals to make career transitions. And for those who are interested in, and for those who are recruiting future talent in the clean energy sector, they need insights on evolving skills requirements and the talent pipeline development. Also, for the industry reskilling strategists, they can get the information about what reskilling and upskilling program they need to design to benefit the workforce from at different stages of the pipeline. And also for the energy policy makers, they can make decisions by getting the information from PACE about what are the evidence-based policy recommendations. So now I'm going to talk about a major work that we have done in this year. So we did a scenario-based skill mapping. So the scenario-based mapping illustrates a way that we use to embed context into a skill indexing process. So we identify and map the core competencies and skills in a representative scenario in clean energy transition. We're going to talk about example about a wind farm development process. So this way mitigates the challenges arising from regional and organizational variations in role definitions. And it enables individuals to focus on transferable skill sets rather than rigid job titles. Because if you look at the job market, you look at the LinkedIn website, there are too many different ways to describe one job position in clean energy. So the way that we use here for scenario-based skill mapping is to remove the barrier between decision-making, career decision-making, and to process these kind of information. So the users can just looking at the skills that is required for different positions instead of focusing on the specific job roles. So it provides explicit and engagement-oriented connections between external workforce capabilities and sector requirement. So this is the life cycle of a wind farm project. So at different stages, we require different technical skills as well as different transferable skills, or we say the soft skills. So what we did is to map out all the skills and competencies that is required at different stages. So we find that some of these skills are technical, so we need specialized engineers and technicians to handle these issues. But also we find a lot of transferable skills that can be leveraged from different other sectors and industries. So we are going to use a few personas and example case studies to describe all these skills and make career transition. So for example, if we have a data analyst from Woolworths, so if they have 10 plus years experience in data analysis, what they can have is a lot of transferable skills, for example, data collection, data cleaning, data analysis, reporting, collaboration, data governance, and a lot of other transferable skills that they learned, like problem solving. So how to involve these workforce into the clean energy sector? So they can use their transferable skills to become a senior energy data analyst in Energy Co, for example, or Essential Energy as a data governance officer. So there are many, many positions available for them as long as they can bring these transferable skills to their new position. And they can learn these sector-specific knowledge and content later after they get the job. And also, if we map out the scenario-based wind farm development process, it will be feasibility, planning, as well as operations. So people with such transferable skills, if they look at the skills mapping, they know how they can contribute to different stages of the project. Another example that we are going to talk about is a graphic designer from a fashion and apparel sector. So it looks like there's no connection between their current position and clean energy, but we do need such marketing and graphic designing specialists in the clean energy transition to engage the stakeholders, for example, the public, social licensing, to be involved in the transition. So the transferable skills that they can bring are creativity, artist, talent, time management, design skills, marketing and branding strategies, as well as the understanding of design principles. So, and they are from non-STEM disciplines. So the transferable skills that they can bring to a clean energy related position includes graphic and digital content designer. They can design very engaged content to intrigue students or intrigue future workforce into the clean energy sector, or brand designer in AGL, or graphic designer in Transcript. So we find all these positions in LinkedIn and Seek. So they are real and authentic positions. And the stages that they can contribute to a wind farm development includes planning and permitting, operation, and decommissioning. Another example that we can talk about is risk and assurance specialist. So this is pretty important because we need to make sure that we have compliance during the project process. So if we have a risk and assurance specialist working for a finance and investing sector, they can bring their transferable skills, budgeting, risk modeling, regulatory technologies, project management, and etc. So the roles that they can play in the clean energy sector includes compliance manager in clean energy financial council or government the government departments, for financial support officer, or a senior risk analysis in Alita Energy. And because of the importance of risk compliance, they can contribute to any stage of a wind farm development. Another good example that we want to talk about is experienced car mechanic. So these are the skills that they will have after 10 or 20 years of experience. And what they can do is to make a career transition to EV sector. So if they want to be an electrical vehicle technician, they can bring all of these transferable skills that they have as a car mechanic, and they can be employed in a bunch of companies that implement EV strategies. And these are the skill gaps that they need to address. So the skill gap is at a minimal level, and the bridging program or the certifications or the trainings that need to take is only limited to, only needs EV technology courses or certification and safety training for high voltage systems. And it is not limited to EV only. So if they want to be a wind turbine maintenance technician, what they can do is to bridge another set of skill gaps. For example, the knowledge of wind turbine systems, mechanics, the motors, or some safety protocols for wind generation and SCADA system. And as long as they take these sector-specific training and programs, they can become qualified in this wind generation programs and projects. And also, they can become solar and PV installers. So because they have hands-on skills, so what they need to address is a few skill gaps in terms of solar energy. So they need to know a little bit about electrical codes and standards in solar installation, and system design and grid connection studies. So they only need to address these skill gaps so that they can become eligible to become a solar PV engineer, installer. So after we look at all these examples, what we want to highlight here is that we need strategic workforce mobility to expand the pool of clean energy talent. Remember, at the beginning of the presentation, we can see that there are a lot of striking numbers that we can see in different reports in terms of the volume of the workforce, and it cannot be possible for the education pathways to make impacts because those are future workforce from the university, from the K-12 schools. So we need to address the immediate workforce need by mobilize these workforce from non-external, non-clean energy external sectors to the clean energy sector. So a large proportion of clean energy skills are transferable from adjacent sectors, from non-energy positions. And cross-sector recognition frameworks and standardized competency mapping are essential. So we are going to implement more authentic scenarios in the future so that people can find their position in different scenarios in energy transition. And the focus for the industries should shift from sector-specific to skills-based credentials. So how can we leverage the institutional support to make the workforce mobility possible? So we are going to talk about two major roles in terms of industry bodies and professional associations, and education and training institutions. So for industry body and professional associations, again, we need to expand the talent pool from adjacent industries without narrowly requiring sector-specific experience. So as we discussed before, we can attract the workforce from non-energy sectors by providing bridging and upskilling programs in terms of sector-specific experience later. And industry needs to develop standardized cross-sector skills recognition frameworks and facilitate transitioning training and work-integrated learning. And more importantly, we need to establish industry-wide transitioning protocols and transitioner mentorship programs so they can learn these sector-specific knowledge with a mentor on the spot. And for the education and training institutions at UNSW, what we can do is to provide flexible, targeted, and work-integrated learning transitioning programs and create modular upskilling and reskilling pathways with micro-credentials, which is the work that I'm doing. So by providing stackable and modular modules for upskilling, we can address the sector-specific knowledge in a very quick way. So which means that these workforce, like aging workforce or very experienced industry professionals, they don't have to get a formal qualification from the university, but they can just finish a very quick short course to bridge the gap between what they have and what they need to do. And coordinate the RPL framework with the skill recognition framework. So university has a very comprehensive framework to assess the prior learning of recognition of prior learning. So what we can do is to leverage the similar framework to do the skill recognition in the industry for cross-sector skill recognition. And the last one is incorporate transferable skills into curriculum to cultivate more versatile graduates. So in the university, in most of the programs, we teach transferable skills in an implicit way. So we don't really tell the student you are learning the communication skills, you are learning the project management skills through the course. So students are learning these skills through different assessment, through the course content implicitly. So what we can do is to make them more explicit, more engagement-oriented, for example, to create a contextualized, scenario-based project so that they can leverage what they learn in the course in a real-world application. So that's what we have to do. So this is the progress for the PACE project. It is a very broad project. So everything that we talk about is some preliminary findings that we have, and we will continue improving the methodology as well as the content, and wish to get any feedback and suggestions for this project. Thank you.